This whole periodic table is actually a system of classification for elements. You can compare this with biology classification. In biology, if you remember, we classify living things, right? Okay, I mean, on the basis of their features like animals, plants, okay, kingdom, phylum, divisions, so many things are there in the biology. So what is the main reason for classification of living things? A simple answer is because we cannot study all the living things individually. Okay, because there are so many living things, right? So if we study them, making different groups, then things will be lot easier. So just to make our study easier, we classify living things. The same concept here you can apply. So elements also are many, right? There are many elements. So studying them individually, I mean, may be a little bit like I mean, time consuming or not very much convenient. So for that, like we have done the classification. I guess that classification is this. Okay, this is the I mean, let's say the latest way of classifying the elements periodic table. Now in this periodic table, now let's say now horizontal rows in the table are called periods and vertical columns are called groups. I hope you understand the meaning of rows and columns. Okay, I mean some of the students sometimes get confused with row and column also. Yeah, I mean do not get confused. This is row. Okay, let me show you this one. Row, right? That's row. ROW row and this vertical. So this vertical is column, right? So now basically periodic table is the table. Okay, table having few rows and few columns. So in this table, rows are called the periods and columns are called the groups. Okay, rows and don't get confused. Okay, you have this horizontal row and vertical column. Some students get always confused there. Okay, the next point there. Okay. Elements belonging to same group have similar physical and chemical properties as elements belonging to same group have similar electronic configuration. Now to understand this thing, okay, let me show you the periodic table, then it will be easier to understand. Okay, I mean keep copying this. Don't worry, I'm just removing this slide for a while. I will just get it back. Don't worry if you have not finished copying. Okay, don't need to panic. I just like to show you that table here. Okay, let me show you that table. Table is somewhere here. Okay, look at this periodic table. Okay, look at this periodic table. So it's a big table you can see here, and rows are there, columns are there. Can you see? Okay, so let's start from here. The first number one. This is like a number one column. This number one column is actually first group. We can say. Okay, first group, right? So similarly, number two is there. That's like second column, second group. So these elements are arranged in such a way that the elements which belong to the same group. So let me write here. It's easy for you to understand. Okay, which color? Okay, let's use this color. Okay, now look at this. Okay, I'm just like marking this one column here. Second column you can see. So there is beryllium, magnesium, calcium. Okay, so these elements all have similar physical and chemical properties. Okay, so this is not random arrangement. As I have already said, periodic table is actually a table containing elements arranged systematically. So in the same column, whatever elements are present there, these elements have similarities in their physical and chemical properties. And in electronic configuration also they have similarities. Let me give you an example of that similarity. It will be easy to understand. Look at this lithium and sodium. Okay, if you try to draw the atomic structure, if you try to see the electronic configuration, then like you will see one very common feature there. Lithium In lithium has 1 electron in the outermost shell. 3 is the atomic number, right? 3 is the atomic number. So 2 electron in the first cell and third electron in the second cell, which is the outermost cell. Similarly, sodium also has 1 electron in the outermost cell, which is what you call valence shell, right? So 1 electron. 1 is the valence electron number and 1 electron is present in the valence shell. Similarly, potassium. In fact, all of them have that common feature, common property. Okay, similar type of trend you can see in other columns also. Okay, here fluorine, chlorine. Okay, let's first see some elements which are familiar to us, right? So we are very much familiar with first 20 elements from hydrogen to calcium. We are familiar, right? We know their atomic structure. We know the electronic configuration. Now you can compare the fluorine and chlorine. Okay, compare fluorine, chlorine. You compare. Okay, one very clear similarity you will find. What similarity is that? Okay, the similarity is the valency, the number of electrons in the outermost shell. Okay, so you can say fluorine has 7 electrons in the outermost shell, right? Fluorine has 7 electrons in the outermost shell. Similarly, chlorine also has 7 electrons in the outermost shell, which means both of them require 1 electron per octet, right? So isn't that the similarity? So in biology, we classify the living things on the basis of similar properties, right? All the vertebrates, that they have got backbone, right? So at least there is to classify the living things in the same group, there must be some similar properties. In the same way here also, in the elements here, the same case, they belong to the same group. That means they must have some similarities, similar properties. Yeah, I hope this thing is clear. So let me clear this drawing. Okay, clear drawings. Okay, now let's get back to the slide there. Okay, where is that slide? Okay, let me get that slide again here. Okay, so please have a look at that. The fourth point, if you have not copied, please do it first. The fourth point, I just now explained the fourth point that the elements belonging to same group have similar physical and chemical properties as elements belonging to same group have similar electronic configuration. The elements which belong to the same group, they have similar electronic configuration and hence they have similar properties. Okay, they have similar properties. Okay, I gave example there. Okay, you can still remember the example there. The lithium, sodium, the first group, right? And there's magnesium, calcium, the second group. Fluorine and chlorine in the second last group there, 17th group there. Yes, so such similarities are there. Similarities in the electronic configuration, and that similarity makes the features similar. Okay, so now the second slide here has a video, so I need to play that video. Everyone, please. Okay, so history. Okay, history of the periodic table. So this is not only history of periodic table. You can say history of the whole classification of the elements here. Okay, let's begin that. And let me show you that video here. Everyone, please keep watching there and stay focused. Again, history of periodic table. This one.
We all know that matter can exist in the form of elements, compounds, and mixtures. When elements were discovered, a proper classification was required for their easier and better understanding. Many scientists adopted different ways to classify them. They tried to find out some pattern or regularity in the properties of elements. The first among them was Johann Wolfgang Dobereiner. a German scientist who in
So please stay focused there. Like in this video, not only periodic table, there are a few more things explained. Okay, I mean there were few more attempts before periodic table. There were few scientists, few chemists who attempted to classify the elements without using the table. The table concept was given later. Okay, so initially there were few more, let's say, unsuccessful attempts to classify the elements.
1829 found some groups of 3 elements which showed similar properties. These groups are called as Dobereiner triads. Here, if we have a look at triad table, we can see that the atomic mass of the middle element is approximately the mean of the atomic masses of the other 2 elements. As this classification was a primitive step, Dobereiner could identify only some triads from the elements known. Other triads did not obey the rule. Hence, the system of triads was not useful. After the failure of Dobereiner's triads, the next attempt to classify elements was done by British chemist Newlands. By this time, 56 elements were discovered. He arranged all these elements in an increasing order of their atomic masses and found that every 8th element had properties similar to that of the first. He compared this to the octaves found in music, and therefore this classification was known as Newland's octaves. However, this classification had its own share of shortcomings, the main points being that Newland could arrange elements only up to calcium out of the total 56 elements known, after which the elements did not show similar properties. Also later, several new elements which did not feature in Newland's classification were discovered. After the failure of Newland's octaves, Dmitry Ivanovich Mendeleev, a Russian chemist, put forward a periodic table that was called Mendeleev periodic table.
Okay, so please now this would be the topic. Okay, this would be our next topic, Mendeleev's periodic table. Okay, so Mendeleev was the first chemist who successfully classified the elements in the form of table. Okay, so that's what we would be learning in the next. So please try to understand in video.
Mendeleev examined the relationship between the atomic masses of the elements and their physical and chemical properties. He believed that atomic mass of element was the most fundamental property in classifying the elements. He arranged the known elements in the increasing order of their atomic masses and their properties, and thus created the first periodic table containing 63 elements, till then known as Mendeleev's periodic table. Mendeleev's law states that the physical and chemical properties of elements are a periodic.
One possible question, okay, Mendeleev's periodic law. So you will have to write that, don't worry, it's there in the slide.
Function of their atomic masses. In the Mendeleev's periodic table, the horizontal rows in the periodic table are called periods. There are in total 7 periods. The vertical columns in the periodic table are called groups. There are 8 groups, numbered from 1 to 8. Mendeleev kept some blank spaces in this periodic table. The vacant spaces were for elements that were yet to be discovered. He named them Eka boron, Eka aluminium, and Eka silicon, and also predicted their properties, which later were found to be correct. When noble gases were discovered, they were placed in Mendeleev's table without disturbing the position of other elements. The Mendeleev's periodic table, however, had its own demerits. Firstly, no fixed position could be given to hydrogen in the table.